सर थोड़ा बड़ा दिखे आप।
फोन थोड़ा चाहिए फोन। Last time I told you that most of the books have not verified this concept. So it's very clear that whenever we are talking about non-unity feedback loop, we don't need to convert it to feedback. That's a wrong concept. So what we need to do, we have so this is a non-unity feedback system where we have a feedback. That's a negative non-unity feedback system. So last time I told you, I have given you introduction that we can't convert it into the unity feedback and then find that. So what we have done, I have told you that if we get an output from here, that output will get multiplied here, this is from C of H of S, and we have error here, and that error will be the difference of input and input. That's wrong. Why? If we are considering an integrator, this is an integrator, okay, then integrator is 1 by S, differentiator, and what basically we are doing here, we are taking the integral of the output and then we are finding the difference between input and integral of the output. That's not a point. Whenever we talk about the error, the definition of error is difference between input and output. That's very clear and very exclusive. Nothing in this case. But in this case, what we are trying to do, we are getting an output, we are integrating it, differentiating it, doing various types of analysis. Then we are saying that the error is the difference between integrated output or a differentiated output between input and integrated output or differentiated output. That's not an error. So I have given you the reference. If you want to go for a complete analysis, Q is there also, but we'll be taking up this topic. We'll clarify this area. Now, let me consider how we can overcome this. So what I have in front of me, if I take a time domain analysis, R of t minus, I have input minus output, that is error, normal. That is error. But this is in the time domain, this is valid for what? This is valid for the unity feedback. But what I am doing here, if I have a constant kh here, then I multiply the same constant here, I can satisfy this equation. How? Now, output is coming. What are the process we are doing in the feedback? I'm not worried about that, what I'm doing in the feedback. But whatever I'm doing, I'm multiplying it with some constant. With some constant. And that constant will make my difference between the input and the output. When that constant is going to make a difference between the input and output, the same constant I'm going to multiply here. All of this is clear? So same constant I'm going to multiply here. Now if I take the same in the S domain, K of H, C of S, this is T of S. But question is, what is the edge of S here? What is the KH? KH is what is the KH here? Can anybody tell me? This is the, you can write down, this is the DC gain of H of S. This is very important. K of H is, I don't want to use this mask. I'm very, I get suffocated now. 2 साल हमें लगा है, ठीक है? पहले मैं double mask लगा रहा हूँ. I don't want to use it. I'm very tired. Okay, now KH is what? KH is basically now DC gain of H of S. So that's very important here. So in order to do the analysis for the non-unity feedback, never ever convert it into unity feedback. That will be completely wrong. Most of the books, I will show you books, 2-3 books in front of me, they have done it, but that analysis is not clear. Even I told you one of the questions from the IIT that was wrong 2014 in the grade examinations. Everybody has got the marks. So let's move further now. It is very simple. Now if I want to say that this, if I want to validate this equation for the unity feedback, then I have to roll back saying that constant doesn't exist, this DC gain doesn't exist, or constant doesn't exist perfectly. This is an equation for the unity feedback. If I have a unity feedback system, then this is a perfect equation because constant doesn't exist, it is between input and output, and that's what we are getting. Okay, so you can write down equations 1, equation 1 to 3rd. Okay, equations 1 to 3rd. So you can write in error. Error we have both, and this you can write down this also in the time domain. That's very simple. Or T. So equations 1 to 3rd are the basic equations for the unity and non-unity feedback loops. Okay, this is for the non-unity, this is for the unity. It doesn't matter if I'm by non-unity diagram, unity diagram, but you have to be very clear. So equations 1 to 3rd are what? The basic equations for the unity and non-unity feedback system. Now let's come to the equation number 2. Okay. Now I have this equation in the S domain. Now what I am going to do? Equation is R of S minus KH of C of S is equal to KH C of S. Now I will try to get the error now. Now error P of S will be R of S divided by K of H minus this will be C of S. So the same equation I want to write in the time domain. P of T, R of T, P of H, T of C. So this is the valid equation for the error whenever we are having a non-unity feedback loop. Okay? So equation 5 you can write down. Equation 5 is the valid equation. Now further I want to do something. Very easy. Now, if I have a closed loop system, how I write a closed loop system? I write C of S by R of S is given as G of S plus 1 plus G of S H of S. Then here, in a closed loop system, it's a closed loop transfer function if I will write down this equation. C of S will be R of S into G of S 1 plus G of S H of S. Okay? Now let me substitute this equation number 6 in equation number 5. Okay, substitute this equation. Once I substitute this equation, I want to get the value of C of S I want to substitute there. So E of S will be equal to R of S by K of H minus this complete R of S into G of S 1 plus G of S H of S. Now what I want to take R of S common, then it will be 1 minus G of S 1 plus G of S. So this is equation number 7, and this is the equation for the error if we have a non-unity feedback. Okay. Now, if we have to find the steady state error, how we have to find? ESS at infinity will be S E of S. You can write down from the final value. You already know final value theorem normally use. Next is steady state error from the final value theorem. Give the steady state error from the final value theorem. What does that mean? That means ESS, we also write it E of infinity will be limit S tends to 0 S E of S. Now that will be limit S tends to 0 S E of S will be R of S 1 PH minus G of S 1 plus G of S H of S. So that should be your steady state error. Okay, but this is valid only for when we do not have any poles or zeros at the. We'll see that later when we manipulate the equation. So I'm not going for the numerical for the time being. Later on we'll go for the time being. You have to remember that if we have to deal with the non-unity feedback loop, then the analysis has to be done like this. Do not convert it into the feedback loop. So I think yesterday I have given some conclusion points or not. Don't convert. Okay? So those points already I have given. Huh? But that no, that's more. So you have to WhatsApp the send candidate to the numerical. I don't get the time in the yard. So let's move. First numerical on the basis of this we have in the case 2017. क्या करें इसको? How you can want to dictate so much time नहीं है. So basically what we have an open loop transfer function. Then open loop transfer function has been given where p is an integer and it's connected in unity feedback. You can send it. You can use your mobile phone. You can take the photo, copy it, question on it, then send it to everyone. You can use your mobile phone not for chatting. जिसने chat किया उसको मैं बाहर यहाँ से फेंक दूँगा. Mobile phones only. टाइम नहीं है, आई थिंक वेस्ट द टाइम ऑन ग्रुप में अपने मेजर ग्रुप है ना. Okay. So what we have been given in the GATE 2017, the question is very simple. Open loop transfer function is given. Open loop transfer function is g of s, blah blah blah. P has been introduced. S raised power p in the denominator. Everybody has got it or not? Keep your mobile phones in front of your desk. ठीक है, हाथ से नहीं चलाने हैं. Keep it in front of your desk. Open your question and zoom it. Okay. So the open loop transfer function has been given, and where p is an integer, is connected to unity feedback configuration. That is also shown. So that I will draw it here. This is today's numerical number 1 from GATE 2017. So we have a simple, this is R of t, this is your g of s, sorry, yeah, this should be c of t or c of s, sorry, right, I don't. Okay, this is R of s in the s domain, this is c of s in the s domain. So it's a very simple question. Simple question, feedback loop has been given, and that's a unity feedback. So unity feedback, we never have a problem. What he has given after that, he has given that steady state error is 0 for the unit step input. Steady state error is what he has given that steady state error is 0 for unit step input and 6 for the unit ramp input. We have to find the value of the parameter p. Very important question. So solution for this is steady state error for unit पहले क्या दिया step input. So ESS for step has been given, which is u of t, and that has been given as 0. First, second, he has also given steady state error for unit ramp. That means ESS for ramp, which is PU of t in ramp domain, is given as 6. And also he has given the transfer function as g of s is given as, this is given s plus 1 s raised power t, then given s plus 3 plus s plus 2 plus s plus 3. Before solving this question, let's have a look. See, he has purposely given two inputs. Why? Because we have to find the value of p. Now, what is the steady state error for the unit ramp? That everybody knows. ESS is 1 by 1 plus kp. For unit step, I'm talking 1 plus kp. Kp is equal to what? Limit s tends to 0, g of s. Fine. That means kp is limit s tends to 0, g of s. The steady state error is complete 0. So that can only be 0 if the denominator is infinite. That can only be 0 if the denominator is infinite. So that means the kp has to be infinite. Then it can be 0. Second term we can see. Let's start. So then from that we have to conclude, 1, it will give us the range of p. Second, it will give us the exact value of p. Let's have a look. See. Now steady state error I will be writing. Steady state error for unit step we know that what is that? 1 upon 1 plus Kp. But Kp is what? Position error coefficient. We know that. I'm writing. Position error coefficient Kp is given as limit s tends to 0, that is g of s. And this also has been given, steady state error for the unit step has been given as 0. So, when this term is 0, what does this mean? That means your Kp has to be equal to infinity. So I can conclude from here. Roll number 9 over here only. It's clear? When this has to be this term has to be 0, that clearly indicates that denominator has to be infinite. When denominator has to be infinite, denominator is nothing but this. So I can substitute here. Kp will be equal to limit s tends to 0. What is this? G of s? S plus 1 divided by s raised power p, s plus 2, s plus 3. This is equal to infinite. Now approaching to the limits, as limit tends to 0. So Kp in this case will be, we'll substitute the 0, 1, 6. So this will be 1 s raised power p into 6 will be equal to infinity. Is it clear? Now have a look here. Now this term is valid only. This term is valid only. I'll continue to write this Kp because I have not substituted limit s tends to 0 because s is still present here. So that's I have to write it mathematically. So what does this say? This will continue to be infinity. This value can only exist if value of the s will exist. That means if value of the p will start from 1, 2, 3, so on and so forth, then only this term will become infinity. If the value of this s will become, if the value of this p will become 0, then anything raised to power 0 is 1, that is 1. So then the value should exist here first. Is it clear or not? If value of p will become 0, then anything raised to power 0 is 1. So we are left with a type 0 system. We can't have anything, we will get 1 by 6. That's wrong. We should get infinity. So value of p will exist only when it will have a value this. So p should be greater than 0. That means it should be greater than 0. And second is then only if p is greater than 0, then only your Kp will be equal to infinity. If it is greater than 0, otherwise it's not 0. That's number 1. So we have got the range. Now coming to the second. Second what we have, ESS for RAM, and it is steady state error. I'm not writing this, please write this, the simple forms where right now, is given as 1 by kV, where kV is velocity error coefficient. Yesterday we have clearly specified these things. We have clearly stated these things. Velocity error coefficient. So velocity error coefficient is equal to what? Limit s tends to 0, and that is s g of s. That has been given. This has been given equal to, I think 6. Yeah, I think 6 it has been given. So this was equation. This is equation 1. Okay. So that means kV will be limit s tends to 0. S, what is g of s? G of s is s plus 1 divided by s is for p, s plus 2, s plus 3. And this has been given equal to 6. Now, out of this what I am going to do, kV will be equal to, this will be s will tend to 1. So this I will bring here, this will become sp, s is for p minus 1. This will become 2, this will become 3, this is 1 by 6. And still I am not use the limits here, kV. Limit s tends to 0, So that will be 1 divided by s raised to power p minus 1, 6, 1 by 6. 1 by 6 and 1 by 6 will get cancelled. One by 6 and 1 by 6 will get cancelled. So what we have, this SP, s raised to power p minus 1 should be equal to 1. So we know from the indices rule, anything raised to power 0 is 1. So p minus 1 should be 0. So p should be equal to 1 in order to satisfy this. Very simple question, 4 answers were there. Because I have to teach you, that's why it's taking time. If a person knows everything, it's not going to take more than 30 seconds. Okay? So very simple question. In 2017 it was asked. Intentionally he has given 2 inputs. One, you will find the range. Second, you will find the exact square. So this is the way you have to find. Okay? So let's move ahead. Next question is asked in GATE 2018. Electrical question to copy of the make it fast. Very simple. कुछ नहीं था ये. It's a damn easy question. पता नहीं किस प्रोफेसर ने डाला ये. हो गया? The second question is, you can read the questions from your mobile phones. Consider a closed loop transfer function g of s, h of s. Okay? And with a negative unity feedback is given. Negative unity feedback is given. G of h, h of s, that means h of s should not be there, h of s should be 1. Very clearly. The steady state error in output for the unit step input is. I'll give 2 minutes for everybody to solve this question. 2 minutes, not 2 minutes, 1 minute is enough. Make it fast, otherwise I will solve it. Please solve it fast. It's a unity feedback, so that means g of h of s should be 1. You can write simply g of s. Open loop transfer function is g of h of s. Here given, no problem. Please don't discuss. It's a case-to-case basis, individual आपके लिए. Don't discuss that. And I will tell you to discuss, then discuss. Want to see what you have to do. Anybody has got the answer? Huh? 0.67. Okay? ठीक है, 2 by 3 square. You should get the answer. इसमें क्या है? कोई बड़ी बात है नहीं. S plus 1 क्या है? S plus 2 है क्या है? S plus 2 है. Unit step दिया है. Okay, this is C of T. Feedback, negative feedback is there and unity is there. So h of s is clearly 0. Okay, solution. Which input has been given? Closed loop, negative transformation, error, and unit step. So, steady state error for unit step is what? Rutba. Rutba is there. You want this? 1 by 1 plus kp. And what's the value of kp? Kp is the position error constant. S tends to 0. G of s. When s tends to 0. G of s is what? S plus 1. S plus 2. It becomes 0. It will become 1 by 2. So, steady state error will be not a question of 30 seconds. क्या दिया उसने क्वेश्चन 1 by 2 है ना ये. Okay, that will become 2. 3 by 2. This is 3 by 2, that will be 2 by 3. 0.67. Not a question of 30 seconds. Year 2018 now. Anyway, let's move ahead. Okay. Now, what was the discrepancy in the GATE 2014 that the professor has asked a question that was wrong? Copy this question fast. IIT में सबके मार्क्स दिए थे उस बार, क्या गलती थी इसमें? Let's see. अपने ग्रुप में फॉरवर्ड करो जल्दी. Okay, read the question on your mobile phone. The question is 2014. See, he has shown error, and that's clearly wrong. If you are talking about the non-unity feedback tool, then error should not be there. This is a wrong. The way the question has been framed itself, that was wrong. So let me draw this for you. Everybody needs to solve it. What are the technique I have shown? Solve it by the technique till the time. So this is our problem third today. It's from the GATE 2014, and there was a discrepancy in this question. First time question was asked from the non-unity feedback loop. आप भी भाई साहब कुछ कीजिए, आप भी कुछ कीजिए, ठीक है? Don't sit idle. So this R of t is u of t. Let us steady state of the step input, and R of s is 1 by s. So what he has written here, E of s or E of t, this itself was wrong. This was wrong. This we should not have it. Why? Because there is something in the feedback. So the question was framed itself wrong. Okay? So you need to find the steady state. Okay, there are no still poles and zeros. Poles and zeros को मैंने बताया आपको, अभी नहीं मैंने बताया. The cases I will take later on. Okay, what is G of s here? G of s will be, this is in cascade, so G of s will be 4 divided by s plus 2. What is h of s? H of s is s plus 4. So what will be k of h? That's a DC gain in this case. I have already told. Limit s tends to 0. H of s, that will be limit s tends to 0. 2 by s plus 4. That is 2 by 4, and that is 1 by 2. So kh is 1 by 2 in this case. So what was our formula for the steady state error in this case? E of s was equal to limit s tends to 0, s r of s 1 kh minus g of s 1 plus g of s h of s. So this was the formula. Okay. So now what kh we have gone, so DC gain in this case. Okay, that was 1 by 2. So what is our input? Input is step. S into 1 step is written as 1 by s. So this is 1 by 2. 2 will go up. Minus g of s. What is g of s? G of s 4 divided by s plus 2 whole divided by 1 plus 4 divided by s plus 2. So E of s I am going to write here. E of s is s and s gets cancelled. S tends to 0. 2 minus, and this is 4 divided by s plus 2 whole divided by s plus 6 divided by s plus 2, it gets cancelled. So limit s tends to 0. This will be 2 minus s plus 2 gets cancelled. So that will be 4 by s plus 6. Okay. मैं कोई गलती तो नहीं की? Okay. S plus 2 ये क्वेश्चन है ना? S plus 6 कहाँ से है? Just 6. Second. S plus 2 it will be s plus 6. As by 2, yeah, that will get cancelled. And that. Oh, HFS is also. Sorry. It's my mistake. क्योंकि हमें यूनिटी फीडबैक की आदत पड़ गई है ना, तो ये बुरी आदत है. This put us in trouble. Unity feedback. Okay, this is 1 plus into HFS भी है ना हमारे पास. HFS क्या है हमारे पास? यहाँ पे आ जाएगा. HFS is 2 by s plus 4, right? Fine. E of s is limit s tends to 0. This will get cancelled, and this will become 2. 1 by 2, and it will go up. Will become 2 minus whole divided by s plus 2. Fine. Then in the denominator, what we can write? 1 plus s plus 2 plus. No need to multiply because we will be getting zeros. So plus 8. Okay. And that will be divided by s plus 2 into s plus 4. Okay, fine now. Now s plus 2 gets cancelled. The denominator E of s will be limit s tends to 0, 2 minus, so 4 divided by s plus 4 multiplied by s plus 4, because s plus 2 will get cancelled. The denominator will have s plus 2 into s plus 4 plus 8. This one. The limit s tends to 0, 2 minus, that will be 16 divided by 8 plus 8 is 16, 1, and answer of this should be steady state error should be 1. That was the correct answer. But how IIT have done, they have got the answer 0.5, that was the wrong answer. How they have got it? They have converted, this is the person here, they have converted this into the unity feedback. How you can convert it to unity feedback? Transfer function for a closed loop system is this one. Okay, so when you do not have a closed loop system, then you need to make it g of s 1 plus g of s. HFS should not be there. First you do it, and then you have to make it, or you can add minus 1 or plus 1, whatever you want to do. That way you have got the answer. What? You have got the answer 0.5 or something. I don't remember. I have not done it. Let me check the answer. Yeah. This way you are getting 4 s plus 4, s plus 2 plus s plus 4 plus 8. Fine. Now if you have to convert it into unity feedback, what's the formula? G of s 1 plus g of s. Instead of g of s, h of s, you have to take it 1. So he has done it like this, and then the answer was, I think he has got answer as 0. 0 something, that was wrong. That answer was not correct. The correct answer is wrong. So this is the way you have to deal with a non-unity feedback. Now next up, there are two cases. If there will be poles at origin, I have for the previous thing explained, I have told you there was no poles, and in this case also you can see there are no poles or zeros at the origin. That much of That much in the deep they will not ask. In the control system, if the gate examination is there, that much of deep questions will not be asked. They will not go into the depth. But still, some professor can ask a question. So then how to deal with it? You can write down two cases. It's enough if you know how to deal with this non-unity feedback, that's all. Case number 1, if there are poles at origin. Case number 1, I'm talking about the same topic, steady state analysis for the non-unity feedback loop. Topic continues. If there are poles at the origin, or sometimes what will happen, they will ask if there are poles at the origin. Then what will be the change in the DC gain? DC gain change will be K of h will be equal to limit s tends to 0, s raised power n h of s. Then DC gain will be K of case mix h will be equal to limit s tends to 0, s raised power n h of s. Okay? S raised power n h of s. So what will be the change in the steady state error now? Shabash. Steady state error. What was the formula? What was the formula? Formula is limit s tends to 0, s r of s 1 by, it was what? It was kh. Now hs you have to take into consideration. So hs will be equal to what? K of h divided by s raised power n minus, it will be the same. G of s 1 plus g of s h of s. This is the only change you have to make. Because you have to get the feedback loop will be there. That formula you have to take into consideration. H of s will be kh divided by this. Second case. Case number 2, if there are zeros at origin. If there are zeros at origin, okay, and what is going to happen? In that case, we'll be writing yes, this should be divided now. Kh should be limit s tends to 0, h of s divided by s raised power n. Then steady state error will get amended to limit s tends to 0, s r of s, and that will be multiplied now kh s raised power n minus n. These two cases, the chances are very, very grim in this case. Chances are very grim you will get a question like this, very difficult. If ever you are going to get a gate examination question, you will get a non-unity feedback, not with poles and zeros. I am sure 100%. Okay? Okay, let's move to the next numerical. पहले करने चाहिए थे तुम्हें ये आप खुद सॉल्व करेंगे I will give 1 minute. Thank you. Today we will finish this. Tomorrow we are going to start root 1234.
1234.
If for the system shown in figure, please have a look at your mobiles, use the technology. For the system shown below, determine the type of the system. Type of the system is very simple for you, not a difficult thing. And the steady state error for the unit step and the unit ramp. Unit step I will do. Unit step you do first. Question is in front of you. Everybody needs to solve on the individual basis. finished, come up with the answers. So the non-English feedback is do clearly and get back to the system. GFS is what? HFS is what? What is the formula? DC gain, limit s tends to 0. HFS, you get HFS and put that in the formula. Very simple. What you are doing? You are not understanding anything? Why you are wondering here? If you are not able to understand, let me tell. Then what you are doing? Answers. User has got this answer right. Answer again. Why? Now क्या calculation है? It's wrong. 2/3 is correct. Whosoever is 2/3 is correct. ठीक है? हाँ जी, आपको समझ आया? सेम फॉर्मूला कुछ नहीं मैंने किया है. नॉन यूनिट फीडबैक को उसने दिया, तो we have finished. Okay. Whosoever will do this question, तो आपको नोट कीजिए यहाँ पे. लास्ट टाइम मैंने 2-2 मार्क्स दिए थे उनने जो ने वो क्वेश्चन किए थे. दिस इज अ वेरी सिंपल क्वेश्चन, बट दिस हैज बीन आस्क्ड इन द गेट एग्जामिनेशन. बिल्कुल सिंपल है. A deaf, dumb and blind can do it. तुम्हें कुछ आ रहा है 6? मतलब तुझे परेशानी है? हाँ? Okay, everybody please check your questions on your mobile phones in the same group. Okay. Bisma is there? No. Okay. फिर आप मुझे बताइए how we can solve this. Now closed loop transfer function has been given, and he has given a notation. Anybody can give anything. ये नहीं सोचो कि g of s को भी कुछ भी notation दे सकते हैं. That doesn't matter at all. Closed loop transfer function of a unity feedback system is given. So that means it is c of s by r of s, which is equal to g of s divided by 1 plus g of s h of s. It includes h of s equal to 1, but unity he has given, that means he has not included the feedback. So now you have to find a steady state error for a unit. For that we have to find an open loop transfer function. How you can find an open loop transfer function g of s? T of s itself will be equal to what? G of s divided by 1 plus g of s into 1. So can you do it and bring it into that form? I'm going to write the T of s here. The complexity of the questions will increase now. जैसे जैसे आगे बढ़ते जाते हैं हर एक टॉपिक में यही तरीका होता है. Simple, then it will be a bit difficult, a bit more difficult, complex, not complex. If you have a concept, I think you have the concept, everything is clear. You have to use your mind only. Now, T of s is given like this. Ask PGS for you yourself solve it, please. T of s is given as an minus 1 into s plus an s raised power n plus a1 s raised power n minus 1 plus 1 and so forth. An minus 1 s plus a. Now steady state in error for a unit step RAM. Okay, whatever you have to find, first you have to find the open loop transfer function. Requirement is to find the open loop transfer function. That means this has to be equal to, I have to put it in this form. Because h of s is given as 1. Negative unity feedback loop. Okay, Shabash. That's correct. No, that's not important for me. Important is what is it? Of the open loop transfer.
an minus 1 into s plus an divided by s to the power n plus a1 s to the power n minus 1 plus log of n.
g of s कहां तक जा रहा है ये? मुझे g of s मुझे यही बनाना है, कहां तक जा रहा है? ये जा रहा है s raised power n a1 s raised power n minus 2। तो मैं आगे क्या लिख सकता हूं उसको? इस a n और s को मुझे अवॉइड करना है। I can write a n minus 2 s square। थोड़ा कॉमन सेंस है, इसमें तो कुछ नहीं है। So this will become my GFS 1 plus same thing. थोड़ा binomial theorem to go back to your class, I think 11th class में binomial theorem। Middle term वो this term, okay? इंजीनियरिंग करने के लिए तो मैथमेटिक्स बहुत अच्छा आना चाहिए, quite normal। ऐसे थोड़ी इंजीनियरिंग की जाती है, आर्ट्स के सब्जेक्ट को रखो, कोई रटने की बात नहीं है, you should have a concept and you have to do it। ठीक है? I think this is correct। बेटा इसको निकालना है, this is the type of a binomial theorem, but you should understand that if you have to get numerator, it will be there in the numerator। Fine। So up to where we have to go? Since this is coming here, so up to here, this is already coming here। ये already आ रहा है, इसने जानबूझ के दिया है ये same चीज। Both the things here intentionally given same। So up to here is coming in the numerator, so that will be multiplied later on। When this will be multiplied, that will be added। So you have to go back. Where you have to go back? Before this term will be a n minus s square। That's all। So you make a transfer function like this। Compare this with this equation। Compare the equation first and second। Now what is g of s now? I'm not writing, but please you compare yourself। Comparing equation 1 and 2, that means g of s will be a n minus 1 s plus a n divided by s n s raised power n a s raised power n minus 1 plus a raised power n minus 2 s raised power 2। Okay, so which input we have given? किसका निकालना है? Steady state error किसका है? Okay, so steady state error for the RAM, ESS for RAM is equal to 1 by kV position, velocity coefficient। So that kV is given as, limit s tends to 0, as g of s, open loop is required here, s tends to 0 as, what is g of s? G of s is a n minus 1 s plus a n divided by s raised power n plus a1 s raised power n minus 1 plus so on and so forth a n minus 2 s square। ठीक है? तो क्या हो जाएगा? इसको नीचे लाएंगे, ठीक है, ऊपर मल्टीप्लाई होगा s से। फाइन, या we can write it like this। ये मल्टीप्लाई पूरा, अगर आप इसको नीचे लाएंगे, नीचे भी ला सकते हैं ना इसको, s raised power minus 1 s n minus 1 बन जाएगा, s सबके साथ मल्टीप्लाई हो जाएगा, तो ये क्या बन जाएगा? नीचे वाला 0 बन जाएगा, ऊपर वाला क्या बन जाएगा? kv। क्या बन जाएगा? तो kv की वैल्यू क्या बनेगी? इंफिनिटी बन जाएगा। तो लाइक दिस यू कैन राइट s tends to 0 s square a minus 1 and then s a n। फाइन, नीचे तो बिल्कुल s है सब में, कोई परेशानी नहीं, नीचे लाओ ऊपर लाओ, इंफिनिटी तो बनना ही बनना है। 0 डिवाइड बाई इंफिनिटी, सॉरी 1 डिवाइड बाई इंफिनिटी हो जाएगा ये वैल्यू कुछ ना कुछ इंफिनिटी हो जाएगा, ये आप नीचे ले जाओ एस इज फॉर -1, आपकी मर्जी है। तो देन so everything will become infinity। यहाँ से एक s निकालो, उसको कैंसिल कर दो, ठीक है। You don't want to write like this, write like this। यहाँ से s एक बाहर निकाल दो, s -1 आ जाएगा ना, कुछ ना कुछ तो आ ही जाएगा। तो एक कैंसिल है, यहाँ पे जो भी कैंसिल करना है, तो then limit tends to 1 by ये क्या बन जाएगा 0, 1 by 0 will tend to be infinity। infinity जब हो जाएगा तो रैंप का क्या आ जाएगा, steady state error will be what, 1 by infinity। ये तो नोट्स में भी लिखा है। गेट एग्जामिनेशन में जो 3 पॉइंट्स का लिख रहा हूँ, 3 पॉइंट्स मैंने कुछ लिखा है। If the type of the system is same, type of the system and the input is same, then what will happen? Finite। गेट एग्जामिनेशन में करने की जरूरत ही नहीं, जिसको वो 3 पॉइंट है उसका दिमाग चलता है तो वो वहीं पे उसको टिक कर देता है। तो ये शॉर्टकट मेथड हो गया वो, लेकिन कैसे आता है, यू शुड नो, यू हैव टू नो ईच एंड एवरी। 3 पॉइंट्स मैंने जो कल लिखा है वो बड़े इंपॉर्टेंट पॉइंट्स हैं। इफ टाइप ऑफ द सिस्टम इज ग्रेटर देन द ऑर्डर ऑफ द इनपुट, यहां क्या है, टाइप कौन सा है, ट्रांसफर फंक्शन कहाँ है, ये ट्रांसफर फंक्शन, ये ओपन होकर ट्रांसफर फंक्शन। यहां क्या कर सकते हैं हम, यू कैन टेक आउट एस, ठीक है। यहां पे भी इसलिए यहां पे 0 आया बिकॉज वी हैव गॉट द रैंप इनपुट, स्क्वायर है यहां पे, ठीक है। तो टाइप इज ग्रेटर, ऑर्डर इज, इनपुट इज लेस, टाइप इज लेस, ऑर्डर इज लेस। 3 चीजें याद रखनी है। एग्जामिनेशन में टाइप नहीं मिला टिक, नहीं तो दिस इज द टेक्निक। एक और क्वेश्चन आप पूछ रहे हो, दो थे, एक की आप होमवर्क रख लो।
सर इसको स्टॉप करना है।